I'm Eric R. Christoph of HoverAndSmile, and this is Combat.
It's sleek, stylish, complex, and expensive. It's none of those. It's rough, simple, and relatively cheap. It's an easily built, foam-based delta wing design with only one mission: to ram itself into another of its own kind. This is airplane cannibalism at its finest. These simple combat flyers are easy to make and as cheap as you want them to be. In this first part of our combat series, we'll be taking a look at how to create a simple combat flyer, from the plans to build one, parts to purchase, and the final construction. As the videos will show overviews, please consult the articles available on HoverAndSmile.com for the details, including plans to download and a recipe list for all components involved. The plans. First of all, let's begin with a simple picture, the plans from the above looking down on your aircraft. Consider a 24-inch tall by 18-inch wide piece of foam. We'll cut away the control surfaces, the parts of the aircraft that will rotate up and down, from the bottom of the foam, and two triangles from the top. The green pieces indicate strips of foam will be adhering to the center of the wing. This builds the fuselage and gives rigidity to the aircraft. The yellow boxes indicate general component placement. The side view shows how the ESC and receiver are going to be recessed into the fuselage for protection. Along with the general area to place the battery, it also shows the rudder and cutting line of the elevons. We've also included an angle on the leading edge of these elevons, which is 60 degrees sanded off the edge. The plans are as simple as that, and although the first construction may take a little time, they become much more easy to build as you get comfortable working with the ingredients. Here's the primary parts you'll need to build a combat flyer. There's an infinite combination of parts to use. This is what's worked out well for us. For more information on the electronic components themselves and what functions they perform, see our Introduction to RC Electronics video on HoverAndSmile.com. We have a 2600 kilovolt motor, 3.2mm prop saver, 8x4 propeller, two 9-gram servos, a 7.4 volt 1000 mAh 20C battery, 2.4 GHz transmitter receiver pair, 25 amp ESC, and a piano wire. The most expensive part here is the receiver and transmitter. A simple 3-channel 72 MHz FM transmitter would have sufficed, but we had these parts on hand already, so we went with our Spectrum 2.4 GHz. Don't worry too much. The electronic components will be recessed, and the chance of a direct strike on one is very, very slim. The firewall, or the motor mount, is simple light plywood, 1/16 or no more than 1/8 inch thick. Of course, the main part of our body is nothing more than Dow Protection Board 3, 1/4 inch thick foam that we've already cut out according to our plans. Most of these parts were picked off of eBay and the foam from Lowe's. Receiver and transmitter aside, the cost of parts is about less than $50. Building the fuselage. We already have cut out our main shape of the flying wing. We'll build the fuselage on the top first by using 4 strips of foam. Note the base strip has the rudder slot cut out of it before we adhere it to our wing. With shorter and thinner pieces of foam, we get a stair-stepped effect along the width and length of the fuselage. This is where we'll be recessing our ESC and receiver. Using 5-minute epoxy available from your local hobby store, apply a very thin but even coat of epoxy to each fuselage piece and place it on your wing, lining it up with the front of your fuselage and centering it along the center of the aircraft. Keep some pressure with either hands or some books for a few minutes, making sure it's still lined up and has made a tight seal as the epoxy begins to cure. Now that we have the fuselage built on top and bottom, we'll match up and sand our elevons. The term elevon is a combination of the words aileron and elevator, as we'll be combining or mixing the functions on our delta wing. The elevons will be rotated up or down by our servos, which means we need to sand an angle on the leading edge of the elevon. Otherwise, movement will not be smooth, causing the elevon to bind against the trailing edge or rear of our flying wing. We'll sand 60-degree angles from the bottom of the elevon, as seen here. Our servos will actually be embedded into the surface of our wing. We'll trace out around 7 inches back from the trailing edge of the wing and about ½ an inch out from our fuselage. Then we'll cut that trace out, making sure there's enough room for the servo arm to rotate. This servo came with a set of arms, so we'll screw the arm on the servo with the screws provided. This is where the piano wire will hook into for the purpose of controlling our elevons. Notice we're facing the servo so the cables can move along the fuselage and up towards where we'll place the receiver. We can further recess the wires into the foam body by slightly cutting into foam, but not all the way through. Then take a small screwdriver to open the slice enough to where the servo cables will fit into the foam. If you cut through, it's no problem, just place some packing tape on the other side of the aircraft to seal it. We'll mount the servo and cables with packing tape later. This is just a placeholder for now. Our firewall is simple light plywood. You can easily place your fuselage pointing downward and trace around it. You'll want to round the corners off the wood, as a corner jutting out beyond the foam can cause the firewall to rip off in a crash. We then take the motor mount that came with the motor and trace 4 dots on both the wood and the fuselage. This is where we'll mount the motor. We're using small wood screws here, so we'll actually drill 4 pilot holes into the fuselage, slightly larger than the screws, and pour epoxy into the holes. Once cured, this will help give the screws something to bite into when we actually mount the motor. After this is done, you can epoxy the firewall onto the fuselage, sanding the foam even if necessary. Drill your holes and mount your motor. Let's move back to our trailing edge for hinges. Packing tape will be used as our hinge, connecting the elevons to the trailing edge of our wing. Recall that we sanded a 60-degree angle off our elevons on the bottom side. Line up the elevon to the outside of your wing and leave about 1/16 to 1/8 of an inch gap between the elevon and the wing itself. This, along with the angle cut, gives the elevon room to move without binding. Tape the top side first, then flip the elevon upward and tape the bottom half. This way, the bottom side of tape will actually follow along the angle and make contact with the bottom side of the wing. Now, we'll take our piano wire, which is a little less than 1 millimeter in thickness, and start lining it up with our servo and the spot on the elevons, where we'll mount our control horns. We'll cut a larger section of piano wire off to use until we're done, then snip off the excess amount. Our control horns are Dubro micro control horns, but you can easily look at the picture and make your own from light plywood or even an old credit card. The control horn is mounted into the elevon about 1/2 an inch back from the edge. Line up the control horn with the servo arm so our piano wire is relatively straight. The control horns are secured into the elevons using epoxy. Once secured, bend a Z in one end of the piano wire so you can twist and secure into the control horn. As for the other end, we'll use Dubro Mini EZ connectors, which screw into the servo arm. Then, the piano wire is placed into the EZ connector and screwed tight with the supplied screw. This lets us make adjustments to the piano wire control rod without having to cut out a new piece. Simply loosen the screw on the EZ connector, adjust, and retighten. With the servo arm centered upward, your goal is to have the elevons be level with the aircraft, as we'll make fine-tune adjustments later, so don't snip the excess piano wire off yet. Leave about 1 inch or so. Finally, we have the mechanisms in place to control our elevons moving up and down. We then mount our servos by placing a strip of packing tape on the bottom of the aircraft over the holes we cut out earlier. Flipping it back over, place the servo into the frame so the bottom side sticks to the tape. Then simply place a strip of packing tape over the top of the servo and our recessed wires. Now we'll place our ESC and receiver into the fuselage. We'll be cutting into our fuselage and picking out layers of foam at a time from the pieces of foam we adhered to the wing earlier. Since we used a thin layer of epoxy, the pieces are easy to cut and pry out. You can also use double-sided tape for your ESC and Velcro for your receiver once you've dug out enough of your fuselage. Note how we cut out a small piece of the firewall for the motor wires to travel into our recessed area for hooking into the ESC. After you've hooked up the motor to the ESC, you can do a simple primer test by hooking in the receiver, servos, and battery, making sure the motor turns and the servos are working correctly. For the servo tests, pulling back on the right stick should make both elevons move up. Up stick makes both elevons move down. Right stick makes the right aileron move up and left aileron down. And left stick will make the left aileron move up and right aileron move down. Disconnect and we'll continue with the final touches. Now that we have all of our base electronics installed, it's time to test the center of gravity. Simply place your fingers underneath the opposite corners where we have our CG line marked. It should balance at that point. If not there, then ideally 1/4 to 1/2 inch forward that line. If you need to adjust the ESC placement, simply move it up or down the fuselage. It doesn't need to be exact, but should be close, given that we still need to mount our battery, which will serve as the fine-tuning point for our balancing. For the battery mounting, place a piece of tape on the bottom of the plane behind our fuselage and attach adhesive Velcro to the taped area and to the battery. Then check your center of gravity again and adjust accordingly. You can always cut a 1/2 inch or so at a time from your bottom fuselage to move the battery upward. Then, by using double-sided Velcro straps, cut slits around the fuselage so we can secure the battery even farther with a simple loop strap going up and over the center of the craft. We mount our prop saver directly on the motor shaft. Given our measurement of the shaft of about 3.17 millimeters, we knew we would need a 3.2 millimeter prop saver for mounting. Prop savers are different from collets in that rubber bands or O-rings are used to secure the propeller to the motor. Either can be used, but prop savers have a tendency to let the propeller bend off the shaft, often saving the propeller in the case of a crash. You can use a rubber band or O-rings to secure the propeller by looping around the opposite screws of the saver. Use multiple O-rings if you go that route. The last piece, which we purposefully left off until the end, is the rudder. Simply epoxy the rudder in place where it fits into the rudder slot we cut out earlier and sits on top of the main wing. Let the epoxy cure and our construction is complete. Apply packing tape over your receiver and fuselage and make sure things are secure, and keep in mind, if anything falls off, packing tape is your friend. Your repair box should consist of tape, propellers, rubber bands, and maybe a little epoxy. In the next video and article, we'll examine fine-tuning points such as propeller size, amp draw, servo centering, and mixing.